Hello, dear students. This is your professor Lázaro Pino, and today I want to explain you something about nomenclature. In other words, naming inorganic compounds, and also we are going to speak about chemical reactions. In the first step, I will explain everything by my own words. In the second and third part of this video, I will use explanations from other professors. So let's begin. In order to classify the inorganic compounds, we are going to divide them into covalent and ionic. The covalent compounds contain covalent bonds between them. And generally, we have a non-metal with a non-metal. Here you have two examples. Carbon dioxide is a compound that everybody knows. And in the other hand, we have the ionic bonds that makes the ionic compounds, where we have a metal with a non-metal. Also, we can divide the inorganic compounds into acids, bases, and salts. Well, what is an element and what is an ion? An element is that contains the same number of protons in the nucleus than electrons in the electronic cloud around the nucleus. The atoms are neutral, while ions are elements that have lost or gained electrons, so they have a positive charge or a negative charge. The cations has the same name of the element, but with the word ion. For example, potassium ion. The anions, we are going to change the ending by "ide." For example, oxygen, oxide. And we add the word ion. The cations, are positive ions, and the anions are negative ions. Let's see. Writing formulas from names. Writing formulas from names of compounds. In this case, the name of the compound is sodium chloride. So we know that we have the element sodium in the first part and chlorine in the second one. Sodium is in group 1A. So they usually have a positive 1 charge because they used to lose 1 electron and get a positive charge. While chlorine belongs to group 7A, where they have several different oxidation numbers, but generally they gain 1 electron to get the octet. A electrons around the in the outer shell of the electronic cloud. In this case, as we have the charge of the cation is positive 1 and the charge of the anion is -1, they cancel out, and all what you have to do is to join, then putting the cation first and the anion after. In the case of aluminum and oxygen, well, aluminum is in group 3A, so he usually lose 3 electrons and get a positive 3 charge. This is a cation. Oxygen is in group 6, so they need 2 electrons to get the octet rule, and or complete 8 electrons in the outer shell. So these 2 extra electrons will provide him with a -2 charge. What do you have to do in order to write the formula? Well, you write first the cation and then the anion, and then the charge of the cation goes as subscript of the anion, and opposite. The charge of the anion goes as subscript of the cation. In this case, we are going to write formulas from the following compounds. Calcium chloride. Calcium forms calcium 2 plus because it's in group 2A. And chlorine forms the anion chloride. So you need 2 chlorides to cancel the charges with the cation calcium. Then 2 negative and 2 positive are canceled out and the compound is neutral. But what happened? In order to have 2 chlorine, you put a subscript 2 here in order to indicate that you have 2 chlorides. Magnesium oxide. Magnesium is positive 2 and oxygen is negative 2. As they have the same charge, they cancel out, and you write magnesium and then oxide. In the case of barium phosphide, barium is 2 plus, and phosphorus or phosphide is -3. Then you interchange the charges and you get this formula. And similar happens with sodium sulfide. When you have binary compounds, always the cation goes to the left and the anion goes to the right. The cation has the same name of the element, while the anion changed the ending by "ide." Like see here, for example, you have estrogen that is Sr +2 and chlorine that is -2. What you do? You use these 2 as subscript of chlorine, and the one that is here goes as subscript of estrogen. But you never write 1 because you always, when you have this formula, you knows that there is a 1 in here. In the case of calcium sulfide, as they have +2 and -2, they cancel both, and the formula is CaS. Here you have another problem. You have cations that have more than 1 oxidation number. This is the case of iron that is a transition element, and iron contains or can have oxidation number +2 or +3. In this case, in order to distinguish one from the other, you have to write the charge using Roman numerals. In this case will be iron 2. In this case, iron 3. For example, here you have copper 2. Copper 2 is copper plus 2. And here you have tin 4. Tin is a representative element, but tin and lead can have 4 plus or 2 plus. So we have to distinguish them by using Roman numerals. In the old nomenclature, usually they call the plus 2 O's in the ending and the plus 4 ic in the ending. Then it could be tin 4 or plumbic, sorry, or stagnic, or tin 2 extagnos. Here you have more examples. In this case, lead have a 2 plus. You put this 2 that is here up as charge of lead, and then it will be plus, lead plus 2. That's why you write here lead 2. In this case, this 3 goes to the iron, so it is iron 3. In this case, oxygen is negative 2, then copper is plus 2. Then this is copper 2. In this case, this 4 goes to titanium, and it will be titanium 4. In the case that you don't have ionic bonds, these compounds are molecular or covalent, and then the form of naming is different. Generally, you have two non-metal elements together. Then you begin naming the first one, and then the second one ends in "ite." But also it's important that the number of atoms that is reflected as the subscript is used as a prefix. If there is only one element, atom, sorry, then it means that the prefix is mono. If you have two, the prefix is di, 3 tri, 4 tetra, 5 penta, and so on, as you can see in this table. For example, N2O is di nitrogen monoxide. In this case is disulfur dichloride. Okay, try this too. In this case is diphosphorus pentoxide carbon tetrabromide, and in this case is nitrogen trihydride. The problem is that in this compound, as in water, you don't use this nomenclature. They have names that are very old, and they remain these old names. In the case of water, water. But in the case of this is ammonia. The acids that are derived from binary compounds, for example, if it is a gas, is hydrogen sulfide. But if it is in water, it's an acid, and then you say hydrosulfuric. Then you add hydro and ic to the name of the element. And then you add at the end acid. Example, hydrochloric acid. Please remember that if the compound is not in water, then you name it as a covalent compound. But if it is in water, then you consider it an acid. Sometimes we have polyatomic ions. The polyatomic ions are made of two elements. Generally, the second one is oxygen. For example, in this case, Cl2 is chloride. Then you add here ite at the end, and this one is ClO3, that is chlorate, and then you end 8. This is what is normal. But there are some compounds like this one that has more types of polyatomic ions. Then in this case that you have less oxygen, you call this hypoite. In this case it's chloro, then you say hypochlorite. But if it were sulfur, you say hyposulfite and so on. It's a hypothetical name. But if you have more oxygen, then you add hyper to the name chlorate. Sometimes it's also known as perchlorate. In the case of polyatomic ions that contains this anion, the name of this is hydroxide, and in the case of CN is cyanide. Well, we have different type of chemical reactions. That one where two elements are combined to get one compound, we call this synthesis or combination. In the opposite case, when the compound is decomposed into two or more elements, we call this decomposition. Single replacement is when the element that is alone replace one in the compound, and then the element that is replaced goes alone. In double replacement, there is an interchange. This cation goes to the place of this cation, and then this cation goes to the place of the other cation. This is a double replacement. And combustion reaction is when you have the reaction between a compound and oxygen. Almost always, this type of reaction produces an oxide, and in the case of combustible reaction that contains carbon, well, they produce carbon dioxide and water. Let's watch this video where this professor give a very good explanation about the classification of the reaction.
Here. Manipulate their and
Well, let's go now to the following video. In the following video, this professor is going to explain you how to balance a chemical reaction. He uses 5 different steps to balance a chemical equation.
Step one. Let's count each type of atom. Sulfur, I have 8. Oxygen, I have 2. On the product side, sulfur, I have 1. And oxygen, I have 2. Note that if there's nothing after an element, we assume that to be 1. And that's it. We're done with the first step. The big rule for balancing equations is that we can only change the coefficients. Those are the numbers in front of the atom. The numbers after the atom, the subscript, cannot be changed. So let's balance this equation by changing the coefficients. If there's no coefficient written, we assume that it's 1. So right now there's a 1 in front of each of these terms. We can see that we have 2 oxygens on each side of the equation. So the oxygens are fine, but the sulfur atom, we have 8 on the left side, reactants, and only 1 on the right. Well, to fix that, I can change the coefficient in front of the sulfur on the right and make that an 8. So if I put an 8 here, that means 8 times the 1 sulfur. That'll give me 8 sulfurs. And now my sulfurs on both sides are 8. But this 8 here is also times the 2 oxygen. And that gives me 16 oxygen. So I fixed the sulfurs, but the oxygens aren't out. I can change the coefficient here, though, to 8, because 8 times 2 equals 16. So now I have 8 sulfurs on each side, and I have 16 oxygen on each side of the equation. This equation is balanced. Step 3, so you don't forget, only change the coefficient. Let's try another problem. So in this equation, we have 2 hydrogen, 2 oxygen, over here 2 hydrogen, and 1 oxygen. How about, let's see, I'll put a 2 right here. So 2 times 2, that gives me 4 hydrogen. So 2 times the 1, that'll give me 2 oxygen. And my oxygens are balanced now, but my hydrogens are messed up. What I can do over here is put a 2 in front of hydrogen, and now 2 times 2, that'll give me 4. And now the atoms on each side of the equation are the same. This equation is balanced. Sometimes we'll have equations that look downright scary, right? But if we have a polyatomic ion on both sides, like the SO4 or the NO3, then we can consider that ion to be just one thing. Let's see how that works. So here's the equation, and I've done my accounting below. You can see I have 1 here, 1 calcium here, and then I wrote the entire SO4 as one thing. And I have 1 of those here, and then 1 SO4, Na, 1, 2 NAs on this side, and 1 NO3, and I have 1 NO3, but that 2 on the outside. So if I put the coefficient of 2 right here, that means I'll have 1 times 2, 2 NA, but this 2 also multiplies across. So 1 times 2 for the NO3s, that gives me 2. And now everything is balanced. So by treating those polyatomic ions as just one thing, it makes it a pretty simple equation to balance. Let's wrap up with one that sometimes gives people problems. So we can see we have 1 carbon, 4 hydrogen, and 2 oxygen. Over here we have 1 carbon, and then we have 2 oxygen, and then we have hydrogen. But be careful, you have to count this oxygen over here as well. 2 plus 1, that'll give us oxygen. I'll start by balancing the hydrogen. If I put a 2 in front of this hydrogen, 2 times 2, that'll give me 4, and that'll fix the hydrogen. But now I have 2 oxygen, but 2 times 1 is 2 oxygen. That gives me a total of 4 oxygen. But that's good, because now if I put a 2 right here and change the coefficient, 2 times 2 equals 4, and now everything is balanced. This video is giving you the basics for balancing equations, but you've got to practice to gain speed and expertise. The more you practice, the easier it becomes. This is Dr. B. Thanks for watching.
Okay, that's all. I hope that you have a good training today.